Kailash Shirodkar, and I am the publisher for Smart Water and Waste World magazine. Before we start, just two instructions to all the attendees. One, a sincere request that you put all your questions that you might have into the Q&A box that is there at the bottom, because this way we can take your questions during the session is going on. Also a request that please don't send any personal messages to any of the panel members, because it might distract them. So thank you. So on behalf of Smart Water and Waste World and Transcend Cleantech, I welcome you all to this interesting discussions that we have scheduled called Freedom from Wastewater on the eve of Independence Day that's happening tomorrow. I have with me Mahesh Shastri, MD for Transcend Cleantech, a leading expert in India in the wastewater sector. I also have Peter Maddy and his colleague Andras from Cyclator, Hungary, who are going to be, the technical experts who are going to answer, all questions with regards to technology and also showcase some interesting work that they have been doing. The flow for the webinar is that we are first going to, discuss about some issues are related to compliance that exist in India. We would then have a small brief presentation from Peter, and then bulk of the time for the session today is reserved for questions from the audience. So to start with, I would like to invite Mahesh to have a chat with me with regards to some of the queries and issues that are facing wastewater sector in India today. So good afternoon, Mahesh.
Yeah. Hi,
Can
good
you
afternoon, Kailash. Yeah, good afternoon.
So Mahesh, the first question that I have for you is that during the lockdown, we have seen media reports and also videos of how the water bodies, across India have, suddenly cleaned themselves or are much more cleaner. So is this, a fair enough conclusion to draw that it is essentially industrial effluent that has been the cause of pollution so far, because industries have been shut during the lockdown?
Yeah, good afternoon, Kailash. Good afternoon to everyone. I was actually under the impression that the industry is the main culprit for this kind of a situation of the rivers and the water bodies. But to my surprise, actually, I could go through some of the reports that CPCB and NGT has published in the public domain. It says that even municipal corporations across board, I mean, right from metro cities to smaller 2-tier and 3-tier cities, the STPs are not being maintained for the kind of degree of level of treatment that they have to do. So it is, I think the major thing is contribution of STP and ETP. It is very easy or relatively easy for the statutory bodies to make compliance for the industry because it's identifiable. But for the municipal corporation, it's a long chain, and it is a bureaucratic chain. So the operator is different, the constructor is different, the maintenance contractor is gone to something else. So it is now starting to, they're starting to dig now. So I have gone through CPCB and NGT and local people. It's both ways actually. It's industry as well as the sewage. And now one step ahead Swachh Bharat has taken is they have started dictating terms on which STPs will be sanctioned. So they will also have mandated the NGT and CPCB that the regulation of ODF has to be followed, and then the STPs, because otherwise the defecated or the decanted sludge, or we can call it as fecal, is directly coming to STPs, and that is disturbing the entire process. So there are a lot of things which are now moving, but trigger is that the water bodies have been seen cleaning, and reasons are, it's simple that it's not been treated, it's just dumped.
Okay. So Can you just share with our audience some of the guidelines that NJT or CPCB have put in place to ensure that, one, there is a greater degree of compliances that companies have to do, and
Yeah.
two, also, does these bodies, NGT or CPCB, have the ability to penalize companies, for the effluent that they are discharging?
Yes, definitely. In 2015, uh, they have. Hello.
Jaya.
Yeah, getting. Hello.
No, that's fine, Mahesh. We can
Yeah,
hear
yeah.
you.
Okay. See, the CPCB and NGT have been pushing, or rather, they were doing their job. But 2017, there was some regulation change, which was by MOEF and other bodies, and they slightly, loosen out than the outlet guarantees or outlet parameters were loosened out. But again, it was 10 BOD outlet nutrition removal from STPs was actually the norm, and it is not been followed now. You go to any state, for instance Punjab or Rajasthan, Gujarat, downstate Tamil Nadu, lot of, you can see in public domain, lot of CPCB work and NGT work happening, where they have penalized, they have taken bank guarantees, they have penalized, they have asked people to comply with, and even industries have been asked to segregate fecal sludge, that is STP, to put STP on that, and industrial waste different, because industrial generally doesn't get the fecal into it, and if it mixes with the fecal sludge, then it can, this kind of a pandemic are effect of that. So they have asked us to, asked all industries to segregate industrial and domestic to be treated separately. The guidelines they have given are same. Actually, there was some confusion, but 10 BOD outlet, a fecal coliform less than 100, nitrogen less than 10, less than 5, phosphorus, COD less than 50. These are all same for STP. And industry, of course, is more proactive, because they then can invest and they can recycle water, they can reuse it. But more so the STPs, and that to domestic, like builder sector or domestic hotels, hospitals, institutions, uh, there I think there's a lot of work to be done. And NGT for last 6-8 months, 1 year, has been phenomenal. Actually, we should, we should appreciate that they have been doing phenomenal work.
So, Mahesh, when we generally talk wastewater treatment or effluent treatment, when we speak to industries, one of the frequent thing always coming up is the high cost of capex.
Mm.
Is that something as a technology solution provider that you believe is that a hindrance for all people, to adopt wastewater treatment technologies?
I think that is not the actual case. If you look at the kind of, or if anybody looks at the kind of investment that a company does, and the kind of damage environmentally it can happen, the same water is going to come back to them. If they pull out water from any water body, the same what has been discharged will come out. So it's not high cost, but we should think of cost of treatment and cost of ownership, rather than, it's an investment. It's not a cost, or it's not a, it's going into drains. It's an investment, and it is a part of the scheme. We shouldn't treat wastewater or waste management per se as a cost, but it is an investment. As you go in future, probably the same water which is now not available, say for instance Panipat, if you look at it, the mills, textile mills are closing down now, because they are not allowed to pull the water, or pump the water from water bodies, or maybe from the pump houses, and they don't have recycling facility. So this is going to be a dead point, that if you don't recycle, you don't operate at all. I remember a scene where in 2000, Supreme Court had given a challenge, or rather they had given a verdict that if the paper mill can't have their own wastewater treatment and recycling, they will have to stop. I think 300 odd mills had to stop in India, and the bigger ones they started. So it is not, it's we call it as a cost, but it should be looked at it as an investment. A second aspect is one should look at the cost of ownership point, from point of view that if I have to treat 1 meter cube of water, what is the cost that I involve? What is the capital cost and what is the running cost? If the combination of capital and running cost, if one looks at it, now government has started looking at it, and the cost of the land, cost of the power, cost of the chemicals, etc. So that makes it, I don't think so that that is the hindrance for treatment per se.
Okay. So just, I mean, I'm breaking my own rule because there is an immediate question that has come up here, which is pertaining to what you were saying. It says, is there any law for who, against people who do not follow the wastewater characteristics?
Yes, of course, NGT has already stopped. I can cite some examples. You can search Google on it, Kalamb near Himachal, or Erode, Tirupur, then you have Rajkot. These places they have given clear-cut notices, and they have stopped this. Now there is a CPHWO. There is an organization which
Yes.
which has been mandated to design and give the parameters. They have clearly mentioned in their manual what exactly is to be done, what are the parameters to be achieved. So the per se law, or per se about the responsibilities and about the what they can expect, these are very clearly mentioned, and it has been n number of times. I would say that there was Ankleshwar, which was under siege probably. Now it's a Konkan belt under siege. The expansions are not allowed. So there has been a lot of effort to make aware about the treatability, or about the kind of responsibilities that a polluter has. So this is now it has reached to the builder level. You know, the buildings that are being constructed, they are to follow 10 BOD norm, and they have to remove nutrition, that is nitrogen and phosphorus. Now this was one of the criteria which was diluted, and now it has started. They are stopping, even builders have been stopped. They have to get the environment clearance, and then there is a committee. They have to present, face them, answer them. So it's very clear cut. I mean, there is no ambiguity about it.
So, Mahesh, one final question before we go on to Peter to share the technical presentation, and then we go to audience questions. Is what are the latest developments on, let's say, wastewater technologies, that could help, achieve or address this problem that we have of wastewater treatment?
Yeah, there are a lot of technologies which are developed now. You can say Mbbr has gone up, then Mbbr, which is again a latest technology. We also have electrocoagulation, but it depends on what kind of flow. I mean, what size of effluent or sewage we are talking about. If it is a containerized thing, say about 300 meter cube or so, then some technology is capex opex wise suitable. There are some technologies which are open, like Mbbr. What we are talking about now, SBR, is an excellent technology for sewage treatment plants, where nutrition removal is one of the criteria. Now it is dominating all the tenders, and now all the tenders are coming for 15 years of O&M. So energy costs have been also asked to be taken care by the supplier, or the maintenance company that is maintaining the plant. So there are different, as capacities vary, there are different technologies. SBR has emerged one of the best in terms of capex and opex for low BOD COD kind of thing. That is maybe STPs or paper mills or that are basically for biodegradable kind of effluents.
So thanks, Mahesh. What we are going to
Thank
do
you.
now is that we are, now that we have laid down a little bit of a background and a base, let's go through the technical presentation and, some interesting case studies that Peter has to share about how wastewater treatment is done across the globe. And then we will have bulk of our time for this webinar dedicated to audience questions. So Peter, would you like to start your session? If you could just give a quick brief about yourself, Peter, that would help.
Yeah. Do you hear me?
Yes, Peter, we can hear you.
Okay, good afternoon, everybody. Thanks the time and thanks the opportunity that we can take this presentation. I'm Peter Madi. We are living in Budapest, capital of Hungary, and alongside with me here is András Mészáros, our main designer colleague at the company. So first of all, I would like to tell you some words that what we'd like to tell you about the technologies. First of all, I would like to show you about our company, some words, how we are making our investments or R&D works, what we see for the future, about the products. Then we will jump into the main topic. This is the Cyclator SBR technology, which is mainly offered for the municipal market. Then we go to the hybridator technology, what we call it. This is an Mbbr technology, which is generally offered for the industrial market. Then I would like to summarize how we can serve you, what is the scope of supply to you, alongside with Mahesh company, because Transcend Cleantech is our exclusive partner in India for these technologies and for products. And then I would like to also show you our own product. This is the Bioduct Decanter, which is we call the heart of the SBR technology. And I would like to also show you some references and some case stories. So first of all, some words about our company. We have more than 25 years experience in the wastewater treatment industry. Approximately now I can tell you that almost we have 400 projects from the past. And as you can see, our revenue and headcount is also growing year by year. And we are investing quite a lot in the R&D. Now we have 50 colleagues in our office. And maybe it's interesting to share with you that our founder and our CEO is Sunny Bashin, who is originally comes from India. We have a nice workshop with 700 square meters. Here we make also for the electrical cabinets and some special product that I want to show you in the upcoming slides. We have the office for the 50 colleagues, and we also have a lab where we can make the measurements for the projects. So for sure, if there is a wastewater treatment project, we would like to see the influent parameters, but many times we also make our own measurements to check the quality of the wastewater. And here is where we make our R&D. Just briefly how we are looking into the future and what kind of other products we also have. This is the ZLD product. It's still, I would say, some test phase. It's already working. We will have this product very soon because now we have 2 test references in Hungary. This is Apollo car tire manufacturer. There's a factory in Hungary where we successfully installed our ZLD product or solution about 6 months ago. We are really proud to show you that we are the very of the first one who has ever made cleaner from the wastewater. We have a complex solution. It's a complex solution. I don't want to go into the details, but we make cleaner from the wastewater in Budapest, and you can see our products also. And it can be both in Hungary, in Austria, and in Germany. And sooner or later, we'd like to take it to the US or to United Kingdom also. And we are really proud of it. And for this, I just wanted to show you that we are investing a lot in the R&D. And we are not just offering, or let's say, old products and solution. We are looking into the future. But let's go and jump into the main topic about the wastewater treatment applications. This is a nice reference photo from one of our main reference where we offer turnkey projects. What you have to know that in the region, in Hungary, we offer design work also, and sometimes we make the construction work also. So for example, in this case, we had a turnkey project, and you can also see 2 decanters in each tanks, which is also designed and manufactured by us. What we can offer to India alongside with Mahesh and Clean Tech, this is the design part and supplying the equipment. How it looks like the Cyclator Mbbr technology, which is mainly offered for the municipal applications. This is a general concept, what you can see. We have the select zone and the react zone as in all the general Mbbr tanks. What is a main feature from the Cyclator? Why is it unique? This is that we have continuous influent. This is one point. There you can see a feed forward pump. This is a unique patent. Nobody else uses it. This is was designed by our R&D team. Why is it good? That we feed the react zone from the select zone with fresh, let's say fresh wastewater, which will help the biological phosphor removal, and that's the reason why how we can decrease the amount of the chemicals to add, so we can save some money on it also. For sure, we have aeration system every time. Generally, we offer the 9-inch membrane diffuser system. If we have denitrification, we also have the mixer. We have an access latch pump, and we have the Bioduct Decanter. This is self-designed, in-house design, and we manufacture it in Hungary, have more than 100 references. The reason why we like it to give it in a big package, then this is how we can give you guarantee. If you give us the influent parameters and the requirements, we give you the design, we can construct it also, and we give the heart of the Mbbr technology. This is the Bioduct Decanter, with the monitoring and control system, which is made in our service. Generally, I want to show you how the cycles looks like. We have 96 minutes aeration, which follows if we have the mixing part, and then we have the settling and the decanting time, for sure, we always check the parameters and what is the requirement. So that's how we adjust how many cycles do we need and how much time do we need for each cycle. But it can be interesting because it's quite unique. This is the FF cycle, where we use the feed forward pump for the biological phosphorus removal, which we use at the settling and the decantation. Some data from a Hungarian project we had some years ago. Just typically wanted to show you what we can achieve with our technology, with our Cyclator Mbbr technology. It was a municipal application with a smaller wastewater treatment plant, where we had 600 BOD with 1,200 COD, and you can see the effluent parameters also. And for sure, we made also the biological phosphor removal, as we use the feed forward. Technology. For sure, it's always we have to adjust that what is the characteristic of the wastewater. So it always depends on. But I think it's good to show you what we can achieve for a general wastewater. I guess everybody is interested. Why should I buy or why should I design Cyclator and not a conventional wastewater treatment plant? It's real parameters or data also from a case story from Hungary, where you can see that the energy consumption can be reduced. Why? Because we use less mixers and less pumps, for instance. That's the first thing. Sure, we can use much less chemicals. The chemical consumption can be reduced dramatically. Why? Because we have this feed-forward technology, which is installed in the Cyclator, as I showed you. The sludge production will also decrease a bit, but the main thing is the footprint will be decreased. Approximately, we say 30%, because we don't need to have post-clarifier. That can be a huge it can be a huge saving also for the construction company. If we see the energy and the chemical consumption, it will be a big benefit for the end users. If you are speaking about the CapEx and OpEx, as I mentioned we can have a smaller footprint, and the construction is quite simple. We give you, I would say, a kind of ready to build design, we call it in Hungary. So it's really easy to install if everything is set. About the technology, just confirming again, one of the main features is the continuous influent. We have the complete biological nitrate removal, and we have the feed-forward pump cycle concept, which helps us the chemical savings by integrated phosphor removal. We also have energy savings with using less mixers and pumps. I think it's quite important thing that we always design for the peak flow, which is generally we design up to 5 times more than the average flow if anything can happen. Nowadays, like in Hungary, in Europe, we have a lot of rainy days and floods, and so that's the reason why we like to stay on the safe side. You can see on the picture one case story. This is a Hungarian wastewater treatment project. You can see our Bioduct Decanter. This is a fixed type decanters and 9-inch membranes also. I wanted to show you that it was a European Union project, and generally in Hungary there are 2 key players. One of them is the end user, and the second one is the construction company. The construction company, as always, wanted to have a low investment cost. The end user, the waterworks, wanted to have continuous influent application or treatment treatment plant, and also they wanted to have biological phosphor removal. And I think you can see that from the past slides that we were the key winners, the key players, that we have the continuous influent. We could give with our biological phosphor removal with the low investment costs also, as they didn't need to build a clarifier, and which was also a big advantage for the construction company, that we have our own decanters, what you can see also, and we could guarantee everything. So we got the influent and effluent parameters, and we could tell to our customer that it's a project which will be made by us using our own decanters. We make the design and we can give you our guarantee, because everything is in one hand, in one package. Just some information data about the project. In Hungary, we can say that it's a bigger project, was 8,000 cubic meter per day. In Hungary, it's big, but we don't have any limitation for the Cyclator, so we can have much more bigger. And the wastewater treatment plant was built in 2016, and it's operating without any problem, any maintenance. I want to show you a video about our Cyclator technology. So we have the React zone and the Select zone also. Here you can see our feed forward pump and the aeration system, which we generally use the 9-inch membrane system. We have the pumps and the mixers, and all sorts of manufactured and designed Bioduct decanters. Now you can see a floating version. We have the cycles, aeration, mixing, aeration, and then the feed forward pump also works during settling and decanting. We have the continuous influent, which is a big feature of our technology. Every time when we make a design, we always give you the recommendation, what kind of products, what type we suggest, but sure, you can buy or you can choose your own one. But we give you a whole package for the design. Now you can see how the feed-forward pump starts to work and gives fresh wastewater to the react zone, which helps the biological phosphor removal. During that time, the decanting starts. I will tell you more about our Bioduct decanter, but you can see that we don't use any external compressor. We use the existing blowers, because if you have a wastewater treatment plant, you should have a blower. So it will help you to save some money, because we can use the existing air what we have on the wastewater treatment plant. Summarizing the main features of the Cyclator technology: continuous influent. We have the phosphorus biological removal because of the feed-forward technology we have invented. We can improve the sludge regeneration. We have kind of low capex, opex, and we have less footprint we need. And we have a unique Bioduct decanter also. Let's continue with the hybrator, which is the Mbbr technology, which is generally offered for the industrial applications. Special media is applied. We start always our calculation with 33% full filtrate rate. I don't know if some of you is not familiar with the technology. I show you a picture how it looks like, this plastic media. There are many types on the market, and this is one of them. And after we add this special media into the tank, then the biofilm starts to grow on it, and then it starts to operate. So some features about how it looks like and what can you achieve, what can we achieve with the hybrator. We can increase the treatment capacity, it also improving the settling characteristic. Operation is at higher suspended biomass. Also, we will have lower sludge production, and we have less area required. Some key information, key features. We will have with this special media, we'll have a fixed film system, which is much more stable due to the establishment of the fairly advanced biological consortiums. We have improved nitrification, because nitrifiers are slow growers, and so providing a fixed film surface allows them a chance to grow in a quantity enough to greatly impact the nitrification. And we have to also know the suspended growth nitrification is harder because the nitrifiers can wash out from the system. And it's also good to know that the technology allows us to treat a much stronger waste in a smaller volume. And as I mentioned, we can add more media. Generally, we start the calculation with 33%, but if it's required later on, you can add more. It looks like a case story. It describes you the best, describes the technology the best. I guess you know also the Suzuki car factory we also have in Hungary. What the Suzuki car factory wanted from us, that they wanted to have stability also under large load variations, because I think like every factory has his own season. So sometimes the production goes up and sometimes go down. So that's the reason why they wanted to have a stable wastewater treatment solution. As always, like in municipal and industrial application, they wanted to have a low investment cost. And the key The key message from the factory to us was that there is the possibility to have a future expansion. They don't want to invest more later on. And why the Mbbr or Mbbr technology is good, that we can add more rough media to the tank, and then it can handle the bigger amount of wastewater. It was 1,300 cubic meter per day, and it's working more than 15 years ago. So what we can give you alongside with Transcend Cleantech, who is our exclusive partner in India. First of all, we give you a basic design and engineering package, even if it's a hybrator technology or a cyclator, which means that we always ask the influent parameters and the effluent also, and we start to calculate what kind of technology we should have to you, we should give you to you. First of all, we make a preliminary design when we can tell the customer that what will be the main dimensions, what kind of products or equipments should we use, and also we give you a preliminary energy consumption and what kind of and how much chemicals you will need to add to reach the effluent parameters. And after it, we can give you the final design also with the engineering package. As I mentioned you, it's a kind of ready to build design. So it's very simple to build it after it, because we give you in a package. I think it's really important for our users, for the end users and the construction companies, that we are the one who also give you the decanters, because it's the key part of the technology. And this is how we can guarantee that you will have the effluent parameters you can achieve. If you follow our design recommendation and you use our decanters, then we give you everything in one package. Sure, we are help you with the startup and the training with our partners. We can help it every time remotely, or when we have local partners, then they will help you. So we will be there from the beginning when we start this design until you have the training. Okay, let's continue with the Bioduct Decanters. Bioduct Decanters. Our decanters is called Bioduct. We have two models, the fixed and the floating type. Here you can see on the right, this is our floating type, which is made of composite material. Now we have 7 sizes, the capacity of 50 to 3,650 cubic meter per hour for single unit. But as on one of the first pictures, I showed you a reference where, for instance, we had 2 decanters in each tank. So it's just only for single units. We have the fixed and floating types. And we have for sure the stainless steel version, but now we developed our own composite material also. We have more than 120 installed references, and we have the experience with more than 25 years. And the reason why it's good for us that every time when we have an own turnkey project, for sure we use our own decanters. So we don't want to sell only a decanter, we sell a whole package, and we have to trust in our product, in our own product. And we have a big reference base and a lot of knowledge with more than 120 pieces reference all around. So as I mentioned, we have the stainless version. Now you can see stainless steel Bioduct 200 version, floating type. We have the fixed type, which we also have in India. I will show you. And we have the new version. This is the composite Bioduct C. Just briefly, some features about this Bioduct C. This is our main product now for the SBR technology. Because of its composite material, it's kind of very lightweight, so it's easy to install. Many times we got the question that what happens if there is no electricity? That the answer is that there is a built-in auto-stop mechanism, so the MNG overflow function then will start. As I mentioned, both of the types, the fixed and floating version, can operate on the process air, so you don't need to buy a compressor to it. And I will show you nice pictures about the scum and solid exclusion, which is very important in these technologies. Some other features that, because of the body is composite and not stainless steel, is totally corrosion resistant, doesn't have any moving part, which we can achieve that it's absolutely maintenance free. I mentioned you that because of the composite material, it's easy to install and very lightweight. And what is the feature that you can adjust the discharge flow? For this type of decanters, for each unit, you can adjust to have between 50 and 400 cubic meters per hour as you wish. Just a video about our decanters. This is the fixed type made of stainless steel, made of 2 or 3 kind of materials, stainless steel material. This is the type what we also have in India. We had in 3 projects. As mentioned, we don't need to use external compressor because we can use the blower. One nice case story, one of my favorite, about decanters. There was a huge problem in a Hungarian wastewater treatment plant where the end user, the water works, asked for helps or for everybody's helps from the market, but we could solve. The problem was that there was a large amount of scum and foam on the surface. So they had problems in the operation. That was the biggest problem. And because they wanted to change the existing decanters, we offered that we'll have a maintenance-free solution because there's no moving part in our technology. And we just told the end user that there's a feature that here they can adjust the outlet flow, as I mentioned you before. And I want to show you how it looks like. There's on the surface, there was a big foam, which has problems for the old decanters. And I think the picture speaks for itself. You can see that we just decant the clean water, and because of the shape, how we designed this type of Bioduct C decanter, we can have the foam and the scums outside of the decanter, and we just decant the clean water, which was very important for the end user and for the technology. We had 45 projects in Hungary where we sold our decanters, in some cases 8 pieces for each. And as I mentioned you, we also had 3 projects in India in the last years, from 1 to 26 MLD. Here we sold fixed type stainless steel decanters to Bundi, Jaipur and Yanshi. This was our project's reference, what we have for our decanters. Some nice reference pictures is about the municipal market. We have smaller and bigger. I just wanted to show that sometimes we make the design part only, and sometimes we make the turnkey project, but every time we offer and suggest or recommend to buy the decanters also, because this is how we can guarantee that the system will work accordingly. Some industrial references, I hope you will recognize many of them. We have good connections and many nice and a lot of references like Procter & Gamble, Bonduelle, Suzuki, SAB, Miller, Henkel, canal industries. So a lot of industrial projects we participated in the past, and now we have in progress many also. I wanted to show you two references from the industry. This was Cal Ingredients, which is a food industry. It was the biggest task was to how we can solve the big COD load. And this is how we managed to solve. Either you can see or you can read our technology. It's interesting that we don't want to offer always the hybrid or the Mbbr technology. For instance, now we offer the Cyclator. We always check the parameters, the influent and the required effluent parameters, and we will design the best solution accordingly. So we don't want to just sell or Cyclator or hybrid or technology. We want to give the solution. Just quickly, an SRB Miller reference from the brewery. This is also where here we used DEF system because that was the best what we could offer and how we could achieve the big COD load. That was my presentation. Thanks for your time. I hope you found some interesting case stories and you found our technology interesting. If you have any questions, we are happy to answer. And if you have any inquiries, even for the technology or for the product, then please contact us or contact Mahesh, the Transcend Cleantech, who are the exclusive partner for India. Thank you.
Hello, can you hear me? Okay. So, now we are going to take questions from the audience. So Mahesh, the first question that I have is from Ganesh Pujari. He is saying that considering the stringent norms CPCB, PPCB have implemented, how justified is it to bring down BOD from 30 to 10? Because the cost involved for changing such norms is almost 500 million INR. Mahesh, you need to unmute yourself.
I don't know 500 million is for what capacity, but we have had about 30 projects, 30 odd projects in the past 1.5 years, where the BOD COD is brought down to a level of 2 ppm, and it doesn't require that high cost. First thing is the norms have changed long back. This is just people have dragged it to maybe till the pandemic or till NGT comes to their doors. So it's not high cost which is going to be incurred for 30 to 10. It is the basic design fault. People assume there was a story that a king asked every citizen to pour one bowl of milk in a in a mandir, and everyone thought that my one bowl of water in the whole lot of milk is not going to change anything. And ultimately, at the end of the day, there was no milk. There was only water, which was on the on the god. So it is this attitude probably when people thought. People thought that typically pani kahan aane wala hai. What people generally, when we talk to the customers or when we talk to the builders or when we talk to the people, is that bahut safety hai. There's a lot of safety. Where there is water is going to come, whether it is 800 KLD or 8 MLD or 80 MLD, there's no water, which is wastewater is not going to come the way it has been taken in the design. But ultimately what happens is sometime down the line, 8 months or 1 year or 2 years, the wastewater has to come. And increasing population, use of different chemicals in the homes and other places, this is going to increase the use of water as well as pollutants. So it is not about bringing down from 30 to 10, which will cost more, but it is the design which was not correct, and that is going to give you a problem. Otherwise, if it is designed properly, I don't think so. The cost is high.
Okay. Mahesh, there is a question from Abid Khan. He says most of the STPs are not working at full capacity. What can be done to overcome this issue?
Yeah, generally when we do designs, or generally a good design, what is done is always done in the parts. You have a redundancy, so that you design such that you have 2 parts or 3 parts, so that there is a redundancy and it can take care of it. The flow is small and you can run only small part of it. Now for SBR, that is not the case. You know, if the flow is less than the capacity, still can run the plant, and you'll get the better results. So half the capacity, you can have modular designs. You can have a smaller capacity 2 plants, or maybe channelized plants. So there are a lot of flexibility in the design that we can offer.
I think, Peter, this question is to you because this came during the presentation that you were doing. Mr. Shailesh Nakate is asking, is there any evidence of a same system already installed in India for industrial wastewater treatment? And two, the second part, he wants some more examples of international case studies. But I think the first part of the question is, do you have any evidence of a similar system already installed in India?
As I mentioned, our founder and CEO, Sunny Bashin, originally comes from India, and I know that they already have some projects where he helped the design. But in the last 10 or 15 years, we can tell that we focused on Europe because there was a lot of EU-fund projects. So this is our new sales channel to go to India also. So we have many references, but mainly in Europe.
Okay. Peter, one more question I think I will share to you and Andras from Shrikant. He says, which technology is better, Mbbr, Mbbr or SBR, considering quality and low maintenance?
Okay. Regarding Mbbr, we can say that the best quality could be achieved, but for operational cost and for investment cost, it is one of the highest. In case of Mbbr, we can say that the investment cost is in the middle. So the media costs a lot. Of course, you can have a smaller tanks, but still the media cost is high. In case of the SBR, you can achieve, as you can see in our case study, really good results. In that case, the operational cost can be the lowest, and still you can have a good quality effluent.
But I would like to add some words to Andras' opinion. All of them were true, but I think it's not easy, and we can say that generally Mbbr or SBR or Mbbr is the best. So every time, as I mentioned in the last 2 references, we always check the parameters, the influent and the effluent, and we have to check and select accordingly. So I think it will be no fair against one of the technologies to say that we don't recommend any of them. We always check what is the need and how we can achieve the best parameters, and we will choose and we will design accordingly.
One more question, Peter, to you and Andras is, how does sludge production get reduced in a cyclator?
The sludge production, due to the FF system, we can have a really good settling sludge. The reason is that the biological phosphorus removal, the main part of it is done by the biomass. This means that the sludge is, let's say, it is heavier. In terms of sludge production, we can say it is fairly the same as other biological plants. So, yeah.
Okay. Mahesh, a question I have from Prashant Chaudhary is, he says in developing countries like India, plants are designed considering 10 years of future projected sewage flows. How do we ensure to run the STB in a stabilized manner at these gradually increasing flow capacities?
First thing is, if it is an municipal wastewater treatment plant, then this is not based on 10 years or 15 years envisaged flows, but they are more so stabilized for a local community. So now there is a phenomena of decentralized, like smaller STPs, say for instance 1 million liter per day to 10 million liter per day. So they are not concentrated. The trend was 10-15 years back, the plants were big plants, 80 mld or 100 mld or so. But now they are split and they are distributed in small pockets. So first thing is that. Second thing is town planning and Jal Shakti Ministry. Now these two different departments, or rather departments have a ministry now. So there is a lot of coordination between them, understanding city development, understanding how the population will grow. There is a lot of interesting data that they are collecting, right from registration of homes to registration of offices, industries, etc. So this data collected is helping them to manage this wastewater also. One of the interesting fact now is, until the sewer lines are laid down, water lines are laid down, ministry is not approving the STPs, and unless until that city has decentralized fecal sludge management, they are not allowing any new STPs to come. So there's a lot of interesting coordination which was probably not happening 10-15 years back, but now it's very interesting. A lot of data which is being communicated across the ministries. So it's more or less now, when we commission the plant, it is 70-80% flow coming, and they also understand if they don't run the plant, it is going to, there will be a lot of replacement cost, etc. So presently, if you look at it, I think with Namami Gange and other river bodies coming into picture, it will be more so PPP projects or hybrid projects, which will be given on 15 years annuity, hybrid annuity contract. So it will be more or less paid based on treatment and not on the basis of whether it is happening or not. So we are getting interesting queries from even Mumbai and across India, that they have to run the plant, and based on the BOD COD reductions or sludge reduction, a lot of parameters are being set, and they will be paid accordingly, and not on whether it is 100% running or 70% no. So it is the parameters, or there is a paradigm shift actually in the way government also is operating.
Okay. Peter, I have a question to you from JN Shri Kumar from the United Kingdoms. He says, how are you measuring the quality of water in real time produced by the wastewater treatment systems that you showed in your presentation?
So how we measure the real-time parameters in the wastewater
treatment systems? How do you measure the quality of water in real time?
In cases when the authorities prescribes certain measurements, then we install let's say COD or ammonia nitrate sensors, but normally there is a schedule, there is a table when accredited laboratory comes and takes sample and then measure the effluent parameters. It depends on the plant size. For small size plants, this is roughly a monthly measurement. In case of bigger plants, it can be weekly also.
Okay. One more question again to you, Peter and Andras, is Mr. Ram Saran is asking whether hybridizers can be designed for oil mixed water, and if yes, have you installed any kind of a plant or terminal in India?
Oil mix. So usually hybridizers. So before hybridizers, the dissolved flotation system is installed. So hybridizer is a low retention time technology. So the TSS is normally removed before it comes to the hybridizer. The hybridizer is very good in removing soluble part. One of our references is Glencore, where crude oil. It is a crude oil manufacturing company where we used hybridizers, a two-step hybridizer. But the first step was, of course, after screening, was flotation.
Okay. Thanks, Andres. A question to you, Mahesh, from Parveen Karla. He's asking, is dewatered sludge stabilized and can it be disposed of in the environment safely without any harm to the soil?
Yes, now this pertains to the first webinar that we did about the sludge disposal, the sludge treatment and sludge disposal. Sludge treatment is now becoming one of the criteria, because till then there was no as such a law or norms for the sludge. But now disposal of sludge has come into picture. There are a lot of different kinds of sludge. There is hazardous sludge, there is non-hazardous sludge. Hazardous sludge, we have a lot of sites nearby to the industrial areas where it is disposed of in scientific way. Non-hazardous, for instance, is basically coming from the biodegradable sludge, and this biodegradable sludge is now has to be treated to class A specifications, and then it can be used as a manure in fields. But for that there are specifications now laid down, and for large quantities, smaller quantities, they have not yet come to the position of class A. But for municipal corporations, they have now implemented class A to be treated. The sludge is not allowed to dispose before it is class A.
Thanks, Mahesh. This question either to you or to Peter. The question is from Ms. Pragati Arora. Is Mbbr technology good enough to reduce the BOD to 10 mg per liter from 300 mg per liter using two-stage Mbbr? I mean,
it is, but we should speak about soluble BOD, because in the hybridizer, one part of the incoming carbon load is transferred to carbon dioxide, but also sludge is generated. So the effluent of the hydrator should be followed a kind of clarifier. We usually also put there a dissolved air flotation system, but mainly yes. So the soluble part can be reduced.
Okay. One more question to you, Peter, is from Kok Lung Gan. He's asking what is the function of the pre-select zone in the SBR tank, and two, what is the sludge retention time in the SBR and Mbbr system?
Okay, the select zone role is first of all it protects how to say, it protects it avoids to have a hydraulic shortcut. So there is no chance that the continuously incoming raw wastewater gets to the decanter when we have a decanting phase. The second is sludge selection. Because of the continuous influent in the select zone, we have a lower MLSS concentration, and due to the raw wastewater, we have a high F/M, and with that we try to achieve a good good settling sludge.
Okay. Again, a question to you, Peter. We have Munish Ahmed who is saying, how can we treat spent broth which is received from a biotech unit? We have a 50 KLD per day plant. Do you have any technology to treat spent broth?
What do you mean spent broth?
Peter, I cannot hear you.
We just asked back that, can you repeat, because we didn't get the point of the question.
Okay. So the question from Munish is, how can we treat spent broth which is received from a biotech unit? Do you have any technology to treat spent broth?
we just don't know what's the spent broth, so we don't understand. So,
Mahesh, would you be...
Spent broth, we need to have the parameters. What is the BOD, COD, and what are the norms of the effluent, input effluent. Generally, spent broth is having very high kind of BOD, COD ratios. So we have to use different combinations of technologies. For instance, we have to use DAF or anaerobic followed by aerobic, or we have to use electrocoagulation followed by aerobic. So there are a lot of, there is no one technology, or there is no one scheme of operation. You have to look at the commercial aspect and how best possible it can be treated. We generally, when we design, we generally calculate what is the cost per kg of load to be reduced. So we choose combination based on that, like SBR, hydrator, DAF or anaerobic. So we choose based on that. So I think if they can share the details, they will definitely be able to give them results.
Okay. Again, a question I have from Ganesh Pujari Mahesh to you is, for large paper mills ETP design, which is best, aerobic plus anaerobic or aerobic plus Mbbr technology?
No, Mbbr or SBR, both are aerobic technologies. So it depends on what is the paper mill's effluent coming. There are a lot of paper mills which are large, but they are running on recycled paper. So there the effluent loads are small. So we can use only SBR or we can use only Mbbr. But when there is an integrated paper mill where the wood or the bamboo, now bamboo is very less, but wood pulp is directly used, for converting into paper. Then there is a lot of processed water from the pulp processing comes in, and then there is a lot of other chemicals, caustic, and gets added to it, and it gets flown into the wastewater. So it depends on what are the parameters. And if it is a recycled paper, then we directly can use aerobic. Only aerobic can suffice. But depends, what kind of effluent data they have. If they can share us, we can definitely give them a solution.
Okay, fair enough. Divakar Tiwari is asking this question. Again, I'm leaving it open. Either Mahesh or Peter can answer this. What is the per cubic meter outlet cost of conventional STP and in either SBR, MBR or Mbbr?
Operating cost?
No, what is the per cubic meter outlet cost of conventional STP and in SBR, MBR or Mbbr?
It depends.
It depends on the characteristic of the wastewater. So I think we can say that 1 cubic meter, to treat 1 cubic meter costs, I don't know, $1, because it really depends on what is the BOD, what is the COD, and all the parameters. This is our answer. So the question is very good, but I think we can't answer it because of the wastewater treatment characteristic.
No, Kailashji, it depends really on how much is the treatment to be done. For instance, if it is a sewage to be treated, 100 KLD, the cost of treating will be relatively high than 1 MLD because of construction. I mean, it has got a bell curve. The cost of treatment goes on increasing to a certain point, say certain capacities, and then it comes down. Because if you have a high volume of water, for instance, like municipal corporation, then you can deploy best of the technologies to reduce the operating cost, because capital cost is one time, but operating cost, manpower, you can mechanize completely. The plants now, what we are designing is completely manless. You can operate it from your from your laptops. Like one of the plant which is working in Bangalore in Titan Industries, is they can control from their laptops. So the kind of mechanization or the kind of automation or artificial intelligence you can use in larger capacity, that justifies the cost. If it is 100 KLD or 200 KLD, you may not be necessarily using the same technology and the same kind of data analytics to understand and control it. So it really depends on what kind of a flow they are talking about and what kind of loads they are talking about.
A question to Peter. Divakar Tiwari is asking, is cyclator or hybrator technology approved by the CPCB or the NJT, which are compliance bodies in India? Are they approved by these two organizations?
Kailashji, this is a very good question, generic to everyone. There is no, I would say, not authority, but there is no provision that these governing bodies can approve certain technologies. SBR per se, or Mbbr per se, or activated sludge per se, Mbbr, these are all approved technologies. What innovations are done, they are not necessarily come under the purview of any approval. What approvals they seek is whatever you do, for end of the day, they need results which are permissible by the Central Pollution Control Board or MOEF. So it's not the technology approval, but it's the approval per se, per project, that what is the kind of technicals you are using. Say for instance, now environment clearance body understands every small aspect of the technology. What are the hydraulic retention times? What are the DO levels that you are keeping, to the minute levels, so that what is the O&M cost? If you give any false O&M cost, they won't approve it. So it is not about whether the technology is approved, but it is about the results that are to be approved by CPCB.
Okay. Another question I have from Caroline is, what is the hydraulic retention time for the cyclator?
So it will depend on again on the wastewater characteristics. It can be 12 hours per day, or 12 hours, or in Hungary we usually design these plants to have 2 days retention time, or 1.5 days, but it is depend on the influent characteristics. It will depend on the temperature of the wastewater. So a lot of things.
Okay. So there is a question I have from Karuna Didi saying, feed forward and excess sludge pumps were discussed by Peter as a specialized pump. What is the special feature of these pumps, and whether it is manufactured by you guys?
The pump itself is not special. So the feed forward system, what is special, as Peter mentioned, with that system we can enhance the biological phosphorus removal by the excess sludge pump. It is a conventional centrifugal submersible pump. Usually we try to design the feed forward system to have the same capacity as the excess sludge pump to spare the redundancy units. That's all.
Okay, a question to Mahesh from Shrikant Bade. He is saying, how much MLSS should be maintained for better quality of water?
Yeah, it depends on which process they use. If they use SBR, in general terms, it is about 8,000 to 10,000 ppm, which is maintained in SBRs. It depends really, but when we go into more details, what is the biosynthesis of the wastewater, and what is the kind of sludge we are using, what is the sludge age, how the sludge is wasted, how it is recycled. A lot of parameters are there, but as a general layman terminology, we can say about 8,000 to 10,000 ppm is generally maintained.
Okay. Brajesh Chaudhary, Mahesh is asking this question. How much percentage of moisture content in sludge after Bioduct decanters is used? Is it available in India?
Can you repeat, Kailash-ji?
How much percentage of moisture content is retained in sludge after Bioduct decanters use?
Okay, I think he has confused about the decanters. Now, what decanters we are talking about here in the presentation is for SBR decanting, and the decanters that he is talking about is for sludge dewatering. So we can answer both the ways, but moisture is specifically for decanters that are used for sludge decanting, and sludge after decanting, the generally moisture is about 85% in outlet of the decanters. There are better ways of reducing the moisture also, like screw press, which we discussed. That is about the sludge. Decanting in SBR is basically to take out water from the settled sludge. So it will always have 100% water.
Okay. A question again, both to either Peter or Mahesh. The question is Mbbr or Mbbr an economically viable option for decentralized small STPs of say 100 KLD?
SBR, to be honest, for 100 KLD, I think it's better to go for Mbbr process for decentralized and it is if it is STPs.
Okay. A question from is, can you tell us what are the standard operating procedures for maintenance of STPs? This is from Dinesh Soni. Sorry, this is from Narendra Modi, Ahmedabad Municipal Corporation. What are the standard operating procedures for maintenance of STPs?
It's a long list, Kailash. We have to probably send him an email or it's a manual actually. If I have to answer this question, it's a big list of instructions. So if they can send us an email or so, we can definitely pass on.
Okay. Another question from Madhu Kumar is, what treatment units in SBR based STPs are responsible for total nitrogen and phosphorus removal?
So for the total nitrogen removal, of course, the biomass, what is inside the tank. Of course, you have to add air to have nitrification, and then if you have to do denitrification, then you have to have anoxic cycles in which the mixers keep the biomass homogenized in the tank.
Okay. Question Mahesh is, Jitendra Malusare is asking, can we use this treated water for potable purposes after all the treatment like membrane filtration, UFR RO, followed by UV, ozone or chlorine disinfection?
Chlorine disinfection. Now this is a very interesting question, because chlorine disinfection now is becoming outdated because it has got carcinogenic properties. Perennial use of that can cause some damage to human beings. So chlorine disinfection is now being replaced by either UV or ozonation. This is just out of the context I said, but definitely water from SBR or Mbbr can be made potable, can be reusable to drinking post UFRO.
Okay. Another question is that, which is related to how do we improve the efficiency and reduce the load of the STPs?
Yeah. See, if you look at the development of the technologies or development of usage of technologies, it gets segregated. How well you can divide the load of the ETP or STP. Say for instance, if you can segregate some of the floating and some of the broader particles through screening, so your 20-30% load on the STP can be avoided by screening. Just because you have put a very good efficient screen, you can avoid that going to the STP or ETP. Second important aspect is you should use an anoxic zone, or you should use an equalization or normalization zone, where the by just adding a small amount of power, you can remove most of the anoxic particles or anoxic load of the STP. Say for instance, ammoniacal nitrogen or phosphorus can be taken care in anoxic zone. So, and then when you have a core 60%, 70% to be removed, there you can use the most economical SBR, Mbbr based on the location, based on the requirement, and based on the what are the characteristics that you want to do, like if you want to do gardening, or you want to toilet flushing, or you want to recycle it for your in industries they use it in cooling towers, they use it in humidifiers, they use it for gardening. So different purposes will have different kind of technologies available for recycling. But if you can segregate basic floating or dissolved anoxic, then the core can be, and this is how economics also will work out.
A question to Peter and Andres is, what is the status of the use of artificial intelligence in wastewater treatment sector, and does your technology have the ability to integrate artificial intelligence or digital technology?
What we usually do is that the Cyclator technology is controlled by a PLC, and the parameters are visualized on a SCADA system. So usually we have an optical DO sensor with which we measured the dissolved oxygen, and according to the measured value, we control the frequency variator of the blower. In terms of the process steps, I mean the aeration cycles, the mixing cycles, settling cycle, and of course decanting cycle is also controlled by the PLC. What we also have is that we have level measurement, and according to the raise of the level, we can postpone the decanting cycle, and with that we are giving more time to the sludge to settle down. This is what we have as an R&D. We started to implement gas measurements, so we try to measure the carbon dioxide and the nitrogen, leaving the surface of the water, because the DO measurement only measures the bulk oxygen. It doesn't give you a direct feedback of the biomass reactions. But this is right now only in R&D phase. So this is what we have.
Okay, Peter, I have a question for you, which I think is a very difficult question, but I need to answer this. One of our, attendees who's kept himself anonymous has asked this question: what are the drawbacks of your technology?
Drawbacks. The drawbacks.
Limitations.
Limitations or drawbacks of your technology.
It is a hard question to answer. Look, what we know, this is a compact technology. Everything happens in the same tank. So I don't know. Compared to a normal activated sludge plant or another SBR technology, I can say anything
Maybe
special.
I can add one thing for the Cyclator, for the SBR, that what we heard from the other markets, that the Cyclator, the SBR can work very, very good. So if we can have very good, effective effluent parameters, and this is the trick, if the construction company or the consultants will follow the rules or follow the designs. So what sometimes we saw that we gave the design that this is how it should look like. please use, for example, 200 diffusers, use that kind of pump. And after 2 or 3 years, we faced that, okay, there's a big technological problem. And we were asked that, is it because of the Cyclator technology? We checked all the parameters, we checked the small details, and we figured out that no, the Cyclator should have worked well, but they were starting to redesign. Okay, we will add another pump, we will add lower walls and so on. So that could be the tricky version, the tricky part, that you should follow the design criteria, what we advise.
Thanks, Peter. Another question that is coming, maybe this is for you, Mahesh. Anurag Chandorkar is asking, are there any CFD simulation studies being conducted in India for improving the performance and efficiency of STPs?
No, I don't think so. CFD study has done anything in India. I don't think so. It is not done, sir.
Okay. Another question from ER Santosanam. How much kilowatt of power a typical 100 KLD STP with anaerobic digestion of sludge will produce?
No, I don't think so. Anaerobic is, see, STP, you have to understand the delta available to create gas from an STP is very, very low. It's a very lean gas. So it cannot produce much gas for burning and producing electricity. I don't think so. It is just more so, or more times it is being used as a treatment process and not as a resource to create energy. Mostly STPs are used, or the anaerobic treatment in STP is used as a process of treatment and not as a resource to generate power. So I don't think so one should go for anaerobic unless there is a huge amount of wastewater, like millions of liters, then there could be possibility. But otherwise for 100 KLD, I don't think so. It's possible.
Andras, a question that a technical question we have got from Anand. He is saying, what type of diffusers are better for Mbbr and activated sludge processes? Are ceramic diffusers better than silicon type?
I think we don't want to give you, we don't prefer to tell you which is the better one. Honestly, I worked for Xylem for 8 years. So my heart is still for Xylem, one part. So I would say the best aeration system is Sanitaire. But András?
We usually use Sanitaire system. We use a special aeration system in case if we have something in the water. So mainly in industrial application. If you have, for example, a lot of calcium, then a silicon coated membrane can be better. If you have a lot of chlorides, then maybe a ceramic can be better. So, but usually for a municipal wastewater treatment plants, we use PDM times the conventional ones.
And just add that I think in the past there was bigger differences between suppliers. Now I would say that there's not so big quality difference. So if we are speaking about Xylem or other bigger products like SSE, it's almost the same quality.
Okay. Mahesh, we have a question from Pranav Kulkarni. How can we measure microbial count of water for quality testing after SBR, Mbbr or Mbbr treatment?
Actually, it's difficult. It has to be taken to, it's called as fecal coliform testing. It's done in NABL approved laboratories across some 15, 16 approved laboratories by Government of India. So fecal coliform has to be less than 100 ppm. So that is being tested. Now I think there is a list published on a website of CPCB that from where you can get the testing done for a BOD, COD and other things.
Okay, a question I have is, recycling of wastewater from paint shop is a major issue. Is there any new technique available, because they are using traditional methods? This question is from Vinod Sonavane.
Yes, actually, biological treatments depend on volumes of the wastewater. So, paint shops, I think they are very low volume but high COD content. BOD is very less because there is a lot of paint content and other metal contents come in wastewater. So, we are on the verge of, trying. We have under trial, but it is electrocoagulation, special electrodes which are developed for paint and zinc chrome plating industry. So biological systems are, so to say, are not very suitable for these kind of effluents.
Peter, one more question I have from Rahul Sakore. He is asking, which media do you use for Mbbr? What is the surface area of it? And the follow-up question to that is, which type of blowers do you use? And what is the noise level of the same?
The specific surface depends on the different cases and the different industries. The conventional numbers are the 500 square meter per cubic meter or 650 square meter per cubic meter. In case of blowers, we usually use Erzen, Robushi, Kézer, Atlas Copco. These are the ones what we usually use. Rotary lobe kind.
Okay. We have had a lot of questions around ZLD, but since we are going to do a separate session on ZLD, I will be taking those questions, in that particular thing. Mahesh, a question is that how can companies target a zero water discharge? Is it possible?
Yes, it is possible. See, we have to do a lot of mass and energy balance. Many industries like textile, which has high consumables, water is becoming a consumable for them. They have started using in cooling towers. They have started using replenishing into humidifiers. They have started using their colonies, what toilet flushings, and a lot of avenues they have found out, and they're recycling them. Maybe 100% recycling would be an aggressive ambition, or it would be a circus for that matter. But I know of many industries who are recycling to a tune of 70 to 80%.
Okay. Question is, what are the present solutions for the treatment of high TDS industrial wastewater? The question is from Said Beg.
High TDS wastewater depends which industry it is coming from. If it is containing a lot of high TDS as well as high TSS, it can be subjected to, like for instance, distillery, which has got very high COD basis and high TSS basis, which can be 60, 65%, 70%. You can treat it and recover gas. You can run a gas engine on it. So it depends which TDS, what kind of TDS it is. If it is a food industry, yes, you can convert this into a gas. You can use that gas for running. If it is a paper mill, integrated paper mill, yes, you can use anaerobic treatment, and you can do that. Many times, if it is an high TDS, then people prefer thermal processes like MVR, mechanical vapor compression, or other thermal processes to reduce the TDS. It depends which kind of TDS it is.
Okay. Jitendra Malusare is again asking a question. How can we do the most probable number MPN test of treated water?
It needs to be taken to NBL approved labs, sir. It has, they only can test these things. Smaller, if it is STP, small STP, you don't need to do that. But if it is really near the water bodies, say for instance, metropolitan cities like Thane, or whereas lot of water bodies, lakes and ponds, then you need to do that.
Okay, again, this question may be relevant to the current situation, but the person has kept himself anonymous. Can we remove the COVID virus from any sewage water?
Yes, we can. It is proven now that certain Mbbr microfiltration along with ozone and or UV, you can remove the virus. The tests are going on, and it is successful.
Okay. Let me just check. There was a very interesting question. How does the Bioduct stand apart from other decanters that are already available in India for SBRs? This is from Hemant Desai.
Peter?
Well, Mahesh, maybe you know more decanters than what we know, so I can tell the features of what Bioduct C.
Yeah.
What I told during the presentation, that it's you can see also on the one of the picture that this has the scum and foam exclusion. Which is because of the shape. It has the composite material. Because of the composite material, it's very lightweight, so it's really easy to install. It doesn't have any moving parts, so it's kind of maintenance free. We will have the total corrosion version quite soon. So I think that's what I can tell you, that the installation and the operation is quite unique, and we can also adjust the outlet flow as I mentioned it during the presentation. So for example, for this type, we can easily adjust that the outlet flow we'd like to have between 50 and 400 cubic meters per hour, which can be a good advantage or feature for the end users. And we, for example, maybe it can be also good to know for a construction company that we always have on stock these composite decanters, so it's ready to ship. So you don't need to wait that you order one and you need to wait until they start to buy the steel, they start to manufacture it. They can leave, or let's say the service, let's say after ordering tomorrow. So these are some of the features.
So a question I have from Maharaja P is, what is the impact of, effect of TDS on Mbbr or SBR efficiency?
Mbbr or SBR efficiency is basically aeration efficiency. When you have TDS, for example, you have 1 spoon of sugar which is mixed in 1 cup of water, and another you want to mix another 2 spoons of sugar. So there will be ultimate limitation will come, and where you will not be able to dissolve any solids into the aeration. Now, basically, whether you go for Mbbr, SBR or activated sludge process, It's the aeration which is the main heart of the system, which is going to reduce along with supplementing MLSS, the aeration oxygen process. So if something is already dissolved and oxygen in the mass form, like kgs of oxygen to be dissolved in water, then TDS becomes an important parameter for calculating the efficiency of aeration. So if you have below 5000 TDS, the alpha, beta, other parameters of oxygen transfer, KLA factor, all these factors has to be formulated in a set of values. If it crosses 5000, then there are some correction factors to be taken, and accordingly the HRT is to be added. So there are process calculations which needs to be done. So important aspect is you keep as much low as possible TDS, if it's possible. If it's not possible, then you will have to disclose, and accordingly the design is to be made.
Mahesh, I have one more question from Ashish Gawande. He is asking, what is your view on the recent draft EIA notification 2020, which is your environmental impact assessment? How will it affect wastewater treatment?
No, see, there is a lot of other aspects which are considered when EIA was formulated in 2020. The more focus was to give some impetus or some boost to the economy. So they were trying to give some relaxations into the EIA studies to be done. Say for instance, now for any construction beyond 20,000 or up and about 20,000 square feet, they are asking for an EIA study, face or submit all the EIA to the EC body, and there has to be due diligence done for all those projects. Today they are asking for higher capacities. So it is nothing to do with changing norms, that they are not changing any norm as such, but they are trying to take fewer projects into EIA. Larger projects they want compliance, but I think now that probably will not happen because it's not yet clear, but they may continue with the same, or they will probably make it more strict.
Okay. Vinod Sonavane is asking this question. Can we reuse polyurethane based paint sludge as a raw material for any other industry?
I don't think so, sir. It is usable. No, I don't think so. No, it is not usable.
Okay. Another question, Mahesh, is how can we treat hazardous wastewater generated in hospitals?
No, first thing is wastewater from hospitals. There has to be a declaration that whether it is a sewage, that is black water, or is it a wastewater. If there are two different streams, then you have to be treating two different streams separately. STP is to be treated separately, and hazardous, that is anything coming out of like the blood or any other coming out portion, is to be declared and treated differently. So you need to have a very good technical or technically sound disinfection before you reuse the wastewater. So hospital wastewater is generally uses Mbbr or SBR, followed by a very good ozonation or UV, which is fail proof, before they use it even in toilet flushings.
Okay. I will take one final question because we have crossed the 5 p.m. time. Mahesh, the question is how to reduce heavy COD and BOD in the textile industry.
I don't think so. It's a heavy BOD/COD in textile, but in any case, textile SBR or a combination of SBR MBR hydrator is the best technology, because the first phase where the high BOD/COD content is reduced in Mbbr, and in second stage SBR is used, so that there is a good settlability of the sludge, and you get a very good clarity of the wastewater. So hydrator is best suited technology for textile industry.
Okay, a question, Peter, to you that has just popped up, in the last minute is this technology suitable for all weather conditions?
Yeah.
Yes, it is. So it has the same limitations as every biological plant. So the deepest or the lowest temperature where nitrification can happen is around 8 degree, and the highest is around 38 or 40 degrees. So every plant, biological plant, has the same. So Cyclator has it also.
So I have one or two more questions that are popping up. So ER Santosam is asking this question: what is the saturation level of aeration for SBR, MBR, and Mbbr, and for ASP as well?
Yeah, you want to answer me, Peter?
You can answer.
Yeah.
We appreciate it.
Yeah, the saturation levels is in terms of oxygen transfer. In India, we conducted about 3 online dissolved oxygen level tests on that is called as SOTE and AOTE tests, standard oxygen transfer efficiency and actual oxygen transfer efficiency. SOTE is limited around 54%. Like if you add 1 kg of oxygen into water, 54% can be transferred to standard water at 20 degrees centigrade. This is the limitation below 5000 TDS. As it goes up, then there is a graph which we can share with the people if they have any specific question. There is a graph of saturation where the oxygen content gets goes on depleting as the TDS goes up.
Okay, a question I have from Nicholas, Obodin, is which membrane technology, Mahesh, is most commonly used in wastewater treatment plant? In
Mbbr,
India.
In India, it is mostly microfiltration, that is called as membrane bioreactor, that is used. It has got cost is a factor, which is limitation in any ways for Mbbr, but it bypasses all other equipments like pressurized sand filter or activated carbon filter, etc. And you can have higher MLSS levels, even 12,000, 10,000, 12,000 ppm. So mostly MBRs are microfiltration levels.
Okay, we have a question from Sunil Kumar Meena. He says, can you give us tips on handling and treatment of saline wastewater?
Saline wastewater is coming from hospitals?
No, it's from CPCB.
Pardon me?
This gentleman is from CPCB.
Okay.
And he's asking, can you give us some tips on how to handle saline, wastewater?
Yeah, saline wastewater coming from hospitals because, or is it?
So as of now, though, I don't think he has mentioned anything, Mahesh, so I can't.
Okay, saline wastewater is generally having high TDS. So depends what is the flow that they want to understand or they want to treat. But mostly saline wastewater we have to correct the pH. DAF, dissolved air flotation units, are best suited for that. You can remove a lot of suspended solids and from there. And then different technologies can be used. SBR can be used, hydrator can be used. I mean, depending upon the steps, the location, the layout requirement, we can design accordingly.
Okay. A question is, what are microbial ways of treating wastewater? This
Peter?
question is from Indian Institute of Soil Sciences, Pradeep Dey.
All activated sludge, SBR, Mbbr, all are microbial based. I mean, they are not physical, but these are biochemical treatment. So it's the microbial culture which is doing it.
Okay. Another question is, which is the best technology to treat wastewater with low maintenance cost and also low total cost?
Depends type of wastewater. If it is a if it is a sewage, it's mostly SBR, because it's construction cost, capital cost, maintenance cost. It can be completely automated. Removal of nutrients, nitrogen, phosphorus is possible. It can meet less than 10 BOD requirements. So SBR is the most economical in terms of STP, sewage treatment plants. Other things we'll have to look at it. What is the BOD COD ratio, TDS, etc. The parameters need to be looked at.
So we have, as I said, come to or answered most of the questions that have come to us. There are some questions that were balanced, which were around ZLD technology, and as I mentioned that we will be doing a separate session around ZLD, and we will be trying to answer those questions later. So coming to the end of this session, I would like to thank all my panel members, specifically Peter and Andres, out there in Hungary, who have taken time out of their schedules to actually do this 2-hour session with us. So thanks Peter, thanks Andres, for sharing your valuable time with us. Again, special thanks to Mahesh, for again, doing this session and sharing this with us. We will be sharing this complete set of questions with Mahesh, and in case there are any unanswered questions, we will be asking Mahesh to give us his replies, and we will share it with the members. So again, thank you very much to Peter, to Andres and Mahesh, and a special thanks to all the people who have sat patiently listening to this session for the last 2 hours. We hope you have found it valuable and relevant, and we will be coming and updating you with a whole lot of other sessions that we will having for you to answer most of your questions. So thank you very much. And yes, Mahesh?
I think we wish all the panelists and the participants a very warm and very joyous Independence Day. We have started these sessions so that we can look at how we can empower India with the green future, or rather a safe future, because the pandemic, which has given us a lot of challenges, lot of questions, lot of opportunities. Now we can look at the way we treat ourselves or our wastewater, our surroundings, environment, country. The way we treat now, it's different. It's a challenge which has been thrown. So I think this eve of independence, we should at least on an individual basis, we should try and commit ourselves for a better future, safe future.
Thank you, Mahesh. And on behalf of Transcend, Cyclator and SmartWater, we wish all attendees a very happy Independence Day tomorrow. So thank you very much, and we will see you for the next session. Thank you, Peter. Thank you, Andres.
Thank you. Thank you all.
Thank you.